Hello and welcome to yet another lecture on Control System 1. Myself Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Degree Engineering College, Electrical Engineering Department. Today my topic is transfer function of electric circuit and the impulse and unit step response of that transfer function. So we have already learned about the transfer function. So what is transfer function? Transfer function is the ratio of the ratio between Laplace output and Laplace input, means the output to input in the Laplace domain keeping all the initial conditions equal to 0. And also we have known that what is the poles and zeros of a system and of a transfer function. Along with that, for the different impulse responses, we also get the nature of the system. It is clearly seen that if the poles are lying on the left-hand side of the S-plane, the system is called a stable system, and the corresponding nature of the response is converging in nature. It's a stable system. If the poles are lying on the right-hand side of the S-plane, the corresponding nature of the system is diverging in nature, and system is called the unstable system. And if the poles are lies on the origin, this is called the marginally stable system, and corresponding nature is also seen. So now we will find the transfer function of an electric circuit. So let us take an electric circuit. A resistance R, capacitor C, and we are taking the output across the capacitor. V suffix O stands for output, and we are giving an input here, V suffix I. This is the input. So this is the resistance R. This is the capacitor C. It will allow a current to flow through that circuit known as I E. So our main objective is to find the transfer function of that particular electric circuit. So it is clearly seen that transfer function is the ratio of, or the ratio between the output to the input in Laplace domain, keeping all the initial conditions equal to 0. So here the output is the V0 and input is the Vi. Keeping all the initial conditions equal to 0, we have to find this one, the transfer function, means the V0 is by Vi is generally known as the transfer function of the system. So let us discuss. You can easily find the value of IT. If this is V0, this part is also V0. So what is the IT? IT is the, so how to find the IT? The current IT. So I, the current IT can easily found, the current I can easily found, it is the voltage difference between the two part, that is VI minus V0 divided by the resistance R. This is the general equation of the IT. It is given that IT equal to VI minus V0 by R. Now I am taking the Laplace transformation of that IT. I am taking the Laplace transformation of that IT. So we will get IS in the Laplace domain. From time domain, we are shifting to the Laplace domain. It is given that I is Laplace domain minus V0 is divided by R, the resistance. So this is the total IS of the system. Now I just take the system to the Laplace domain. So in order to take the system to the Laplace domain, first of all, we have to take the output from that particular system. Okay, so we have to take the output. Output is the V0. So what is the output V0 of that particular system? For that particular system, what is the output V0? So V0 can be written in the time domain is 1 by C. It is the voltage across the capacitor is known as V0. It is given as V0 equal to integration of I t in the time domain dt. So now I am making the Laplace of that particular V0. So we get in the Laplace domain is V0 is equal to 1 by C. Due to the present of the integration, it will be 1 by C is into I is. Means we are shifting from the converting the output V0 in the form of V0s. So what we have seen, what is the change that we have seen if I drawn it in that particular circuit? I am taking this R will be remain R. This will be gone for VIS. V0 will be gone for V0S. And I now became IS. So what is the change of C? C became 1 by CS. So this is shifting the total circuit from the time domain to the Laplace domain. Let's see what are the changes that it is going into the when it is transform the circuit from the time domain to the Laplace domain. So what are the changes that made VIT became, means V at the time domain became VIS, V0 became V0S, R will be remain same, I became IS, and the capacitor became 1 by CS. Okay. Just follow those how it is shifting or changing the circuit from the time domain to the Laplace domain. How the circuit is changing. Okay. So it is clearly written as all the initial conditions are 0. So from the first equation, Is is given Vis minus V0s by R, means Vis minus V0s into 1 by R. So if I take Vis and V0s and multiplying with 1 by R for gain factor, we are getting Is. Okay. So what is the second part? From the second part, we get Is equal to this one. Is equal to Is into 1 by Sc equal to V0. So Is into 1 by Sc equal to V0S. So combine the both part. Our input is Vi, our output is V0. So Vis having is coming to the summing point and multiply with that R by S, we get Is. So Is is multiplying with the 1 by S, we get V0. And the feedback is coming here. So what we have done? We have done that we already have Vi from the, it is coming to a summing point. Okay, this is called the VIS. VIS Laplace domain. Okay, so it is multiplied by gain factor called 1 by R. And what is the output? The output we get from here is the Is. The output we got from here is the Is. This is the first part. Now from the second part, when Is is multiplied by 1 by Sc, we get the V0Sc. So let this Is is multiplied by 1 by Sc factor. We get V0S. And now we are taking a feedback from here to here to make a closed loop system. That we have done, closed loop system. Now what is the transfer function? Our main motto is to find the transfer function. So transfer function is V0S by V0S by VIS is, after doing all the calculation, the transfer function that we have found, from that closed loop system, keeping all the initial conditions are equal to 0, that V0 is that V0, V0 or say VO is by VI is equal to 1 by 1 plus SR3. This is the transfer function that we have get from that particular electric circuit. Now I am taking the impulse response of the system. So if I take the impulse response, that is the Laplace inverse of 1 by SRC, it will give IR equal to 1 by RC into to the power minus T by RC. So it is seen that the response is decay in nature, and the time constant is tau is the RC of a RC circuit. Okay, so what we have told, that I have told now, if I take the Laplace inverse in order to find the impulse response of 1 by 1 plus SRC, what I will get, the impulse response will be getted as 1 by RC. 1 by RC into e to the power minus t by RC. Okay. So this RC is generally known as the time constant of the system. And the nature that we have obtained from the graph, that is the impulse response, is the decaying in nature. Okay. So now we are concentrating on the step response of the system. So if the step response means we are given a step input, means that I have just, that is that we have given step input ut equal to 1. Okay. So for t equal to 0 to infinity. So what is the us, the input? Us became, if I do the Laplace, it will be 1 by s. Okay. So this is our VIS, our input. Means the term that is called the step response means we have to obtain the response, means the output if I give a step input. So what will be the V0S? V0S is the 1 by S into, just taking the RC common, 1 by RC by S into 1 plus RC. So by the partial by fraction we just get that particular equation. So taking the Laplace inverse, it equal to 1 minus e to the power minus t by RC. Okay, this is the response from a unit step input is given to a system, the corresponding output that we have obtained. Okay, so today that we have learned about the how we can find the transfer function from a circuit, electric circuit. It is the output versus the input in the Laplace domain, and how we can construct the entire block diagram, means from time domain how we can shift the block diagram into Laplace domain, where we obtain that the R will remain same, but V suffix I, the input become VIS, the output became V0S, current that is became IS, and the change in the capacitor became 1 by SC. And because it is, we are doing the integration. So converting the integration to the, from time domain to the Laplace domain, we are using SC. S will become, so we total formation will become IS by SC. So we will find the transfer function and the time constant that we have obtained, and along with the first thing that we have obtained, the impulse response, which is find that the response is the decaying nature, and second the step response, means the step function ut equal to 1, it is given, and response means the output that we are obtaining from the state function. It is 1 minus the power minus t by RC. So it is clear that the nature of the impulse response of a system is decaying nature, that we have totally obtained, along with the transfer function that we have obtained from electrical circuit having R and C in series, is the 1 by 1 plus SRC. So we have learned about the transfer function, how to find the transfer function from a electric circuit, and what is the responses when an impulse response, means the impulse function is given to the system, and what is the, when a step function is given to the system, what is the response. Thank you.